In today's lesson, we'll be solving for a variable. We'll have two objectives. We will preview the steps for solving for a variable, and then we will actually do some solving for variables using those steps. Let's begin by looking at the steps. Step 1 is to clear fractions, and this is a step we have not been doing before on solving equations, but we will need to do it this time. Then we'll need to isolate the terms with the variable for which you are solving on one side of the equation. If two or more terms contain the variable for which you're solving, factor the variable out, and then multiply or divide to solve for the variable. Now what we want to do is try some practice problems here, and I'm going to give you that list of steps up at the top of your screens so that in case you need to refer back to them, you'll have them handy. Our problem will be d is equal to rt. Now this happens to be the formula for distance. Distance is equal to rate times time. But if you did not know that, it would not keep you from being successful with what we're going to do now. First of all, it says solve for the given variable. Well, I haven't told you yet what to solve for, so at this point you could do nothing. Once I tell you that I want you to solve for r, now you have a starting place, and I want to tell you what your outcome should be. We're going to try to have a line at the bottom that says r is equal to everything else. We want r by itself, and we will have solved for r. In order to do that, our directions say to clear fractions. Well, I have none, so I don't need to do anything there. It says isolate the terms with the variable for which you are solving on one side of the equation. What that means is all of the r's need to be on the same side of the equation. Well, I only have one r. It's on the right-hand side, and that's perfectly okay. If two or more terms contain the variable for which you're solving, factor the variable out. What that says is, do you have more than one r? And the answer here is I don't, so I don't need to do anything about that. And then it says multiply or divide to solve for the variable. Well, this r has been multiplied by t, so in order to get rid of that, I will want to divide both sides by t. The t's will cancel, and what I'll be left with is d over t is equal to r. Now I recognize that for some of you, you would like it better if it said r is equal to d over t. You'd feel more comfortable that you have solved for r, and that's perfectly okay. You don't have to turn it around, but if you want to, that's fine. Let's look now at another problem. Once again, I'm going to give you your list of steps, and here's the problem. A is equal to pi r squared. This happens to be the formula for calculating the area of a circle, but you wouldn't have to know that in order to continue with the problem. The first step is to clear fractions. We have none, so that step is done. Isolate the terms with the variable on one side of the equation. Well, I haven't told you what the variable is yet, have I? So let's look. We want to solve for pi. So now I know that that's what I'm trying to solve for. So now we need to isolate everything that has a pi in it on one side of the equation. Well, guys, there's only one pi. It's right there, so it's on the right-hand side of the equation, and that's fine. There are no other pi's, so step 3 is also done. And then it says multiply or divide to solve for the variable. The pi has been multiplied by r squared, and I know that you're not used to seeing r squared there, but it's not a problem. I can still divide both sides of the equation by r squared. These will still cancel, and I will end up with a over r squared is equal to pi. And I've arrived. I don't have to turn it around, but if you want to, you can. Let's look now at another problem. And the best way I know to do this is just show you several examples of the various types of problems you could encounter. Our problem this time is P is equal to 2L plus 2W. I want to solve for L. I'm going to circle it because that'll help me remember what I'm trying to get by itself. I'm going to end up with a line that says L is equal to everything else. I'm told to first clear fractions. I have none. I'm now to isolate the terms with the variable for which you're solving on one side of the equation. I want things with L's to stay here and things that do not have L's to go away. Well, to make this go away, I need to simply subtract 2W from both sides. And when I do that, I get P minus 2W. Notice they're not like terms, but I can still write them as if I am subtracting them. These cancel, and on the right-hand side, I have is equal to 2L. Now refresh your memory on where it is you're trying to go. I want to get this by itself. Well, it's been multiplied by 2. So in order to get rid of that, I will need to divide this side by 2 and this side by 2. These will cancel, And what I'll have here is P minus 2W divided by 2 is equal to L. Now, this is our final answer, but I do want to make sure that you understand something. I have some students who will want to say, can I cancel here? And the answer is, no, you cannot, like I've done it there. But let me show you what you could have done. You could have said P divided by 2 minus 2W divided by 2 is equal to L. Then you could have canceled here, and your final answer would have been P divided by 2 minus W is equal to L. This answer and this answer are equally good. You just simply cannot cancel the 2's here and tell me you're okay. Let's look at another problem. Once again, there are your steps, and this time I have Q is equal to C plus D divided by 2. And I'm to solve for D. I'm going to circle it so I'll remember where I'm going. And this time I do have fractions, because it tells me in step 1 to clear fractions. Well, when I have a 2 in the denominator, the step is to clear fractions by multiplying by that denominator. So let's look at how we'll clear those fractions. On this side, I will need to multiply by 2, and on this side, I will need to multiply by 2. I think it helps me a little if on this side, because this is a fraction, I write the 2 as a fraction. On this side, the Q is not a fraction, so I just wrote it as 2. Remember, 2 and 2 over 1 are exactly the same thing. What happens, though, is that the 2's now cancel, and what I get is 2Q, right here, is equal to C plus D. And you'll notice that denominator is now gone, and that's our goal. Now, help me out again. We were trying to get to right here. Well, it says I am to isolate the terms with the variable for which you're solving on one side. I need everything with a D over here and everything else to be gone. So I'm going to subtract C from both sides, and what I'll have is 2Q minus C, these eliminate, is equal to D. And I have arrived where I'm trying to go because I wanted D by itself. You can turn it around if that makes you feel any better. Let's look at another one. A is equal to 2 pi RH plus 2 pi r squared. This time we'll solve for pi, which means I'm trying to get this by itself and have a line at the bottom that says pi is equal to everything else. That's where we're trying to go to, and it's going to be a little different this time because there are 2 of these. So we will have to do that third step that we haven't done yet. What it says do is clear fractions. Well, we have none. It says isolate the terms with the variable on one side of the equation. Well, we're trying to solve for pi, and they're both on the right-hand side, so step 2 is done. It says in step 3, if 2 or more terms contain the variable for which you are solving, factor the variable out. What that means is on this side, I'm going to pull out a pi, and if I take a pi out of this and a pi out of this, what I'll be left with is 2RH plus 2r squared. So my next line will be A is equal to, there's the pi that we pulled out, and here's everything that was left and everything that was left. That's the step 3, which says factor out the variable. Now, let me remind you, we're trying to get this by itself. It's been multiplied times all of this. So our step will be to divide both sides by all of this. And I'll do that over here as well. 2RH plus 2r squared. These will cancel. I know they're big and ugly, but the rules are still the same. And what I'll be left with is A over 2RH plus 2r squared is equal to pi. Once again, you can turn that around if that would make you feel better. Let's keep going now and look at this one. This is probably one of the most important problems you will have in this entire lesson, and it's because this one is going to show up through the whole rest of the semester. Every time you try to graph a line on your calculator, this is going to come into play, and here's the reason. What we're going to solve for is y. Anytime we want to graph a line using your calculator, we will have to have the equation written in the form y is equal to everything else. So this is going to be crucial for everything you do from here on out. we're to solve for y, meaning I need to get that on one side all by itself. Well, this time my y is right here. This whole piece here needs to get out of the way, so I will subtract it from both sides. When I do that, I'm left with 5y, because these canceled, is equal to 10 minus 2x. Now these are not like terms, so you cannot combine them. And my next step is I want y by itself, so I'll need to divide this by 5, this by 5, and this by 5. And I truly do believe it's easier if you just go on and break it into two pieces and divide every piece by 5. When you do that, these cancel. By the way, 10 divided by 5 is just a 2. And so what you would have left here is y is equal to 2 minus 2 over 5. And the x can be written out to the side if you want to do it that way. I personally like it a little better if you go on and turn this one around. Y is equal to negative 2/5 x plus 2. I know that right now that doesn't seem like a big deal to you, but I know where we're going, and that's going to come into play later on. So I would suggest that you just get used to writing it with the x term coming first and then the constant term. Let's look at another one of these because this is so critical. This time I have solved for the given letter, I have another equation, and we're going to solve for y again. You may want to stop the video and see if you could successfully do this one, and then come back and check your answer. Our first step would be to subtract 3x from both sides. When I do that, I'll get negative 5y, and please make sure that you keep up with that sign right there, is equal to 8 minus 3x. Now remember, our goal is to get y by itself, and it's been multiplied by a negative 5. That means I'll need to divide this by negative 5, this by negative 5, and this by negative 5. These will cancel, and the rest of these are pretty ugly, so they're going to stay just like they are. So what I'll have is y is equal to, and I'm going to write it exactly as I have it here, 8 divided by negative 5 minus 3 divided by negative 5x. Now, I would suggest at this point that you move those signs to the numerator of the fraction. I just think for most of you it's a little easier to see what's going on. And remember, it doesn't matter which one is negative as long as one of them is negative. So I'm going to write this one as negative 8 over 5 minus negative 3 over 5. And the reason I did that is this. When I am subtracting here, I'm adding the opposite. So this will turn into negative 8 over 5 plus 3 over 5x. And then remember, I'm always going to put that x term first, so I have y is equal to 3 over 5x minus 8 over 5. Guys, I cannot emphasize enough to you how important it is for you to nail these steps in solving for y. The others are important, but this is absolutely crucial for your success in the rest of this course. I'll talk to you again soon. Let me know if you have questions. Bye-bye.